All right, everybody, we're back again with part 2 of the live broadcast. It looks like things are coming up nicely. Today we are going to be picking up where we left off. I'm going to close out of this on this. So last time on this little series for messing around with some overlays, some identity, and some sCrypt contracts here on the BSV blockchain, we built a little front end. And this front end application, you know, it's a little rough right now. We got increment and decrement. We can kind of see some counters that we were building with an sCrypt contract. So for those just joining in, the idea is to build an app using the BSV blockchain where people can publish little counters that can go up or down, and everybody can see them and make them go up or down. And that way, you know, we can all kind of enjoy this shared, you know, set of you know, counters. So let me just go ahead and make sure that I'm actually live. It looks like I am. So that's good. So here we are. That's good. Okay, perfect. So, picking up where we left off, last time we built this user interface and we got to the point where if I pull up the code again using VS Code, we can see that we had our little handler that when you create a new token, a new little counter, we're calling these meters because the app is called meter, right? They can go up or down. We create an sCrypt contract. And then we create a transaction and put it on the blockchain. And we convert that transaction into beef format. And then we go ahead and broadcast it out to an overlay network. And we're printing out the results, saving the new meter in our little list here. And then that's about it, right? But of course, if we go back to our user interface, we don't yet have an overlay network. So the error is no hosts are interested in this transaction. And I'm going to try something. I'm going to try to do this on the fly here. I know that my bit rate isn't the best right now, so I'm going to try to increase my screen sizes on a lot of this just to make it a little bit more legible for everybody, hopefully. And as we, of course, move on, we'll see how this is going to work. But I think that should be all right. And I'm also going to just make sure that I have only one terminal at a time. So if I want another terminal, which I do, I can go ahead and say, you know, give me another terminal, like that. So now I have two, but they're fairly well larger than they were, hopefully, and can tab between them. Right, so there's my Webpack, and then that's the second one. Oh, I see. This is a bash terminal. I don't want bash, I want Z shell. Anyways, yeah, so today we're actually going to be building the overlay side of it. So we've got our front end folder here, and we're trying to build this transaction. But on the overlay, the question is going to be, you know, what does that look like? So we need to deploy an overlay services node, an overlay services instance to the network so that we can actually, you know, learn about any transactions that get broadcast. We can track those transactions and do all of that stuff. So how do you build an overlay network, and how do you then use it for tracking, you know, particular types of transactions? Let's just recap here with a little demo. If I refresh this page, what's going to happen is I have some dummy data populated. I'm just going to get a new one created here, and it's going to ask me for, you know, creating that. I'll go ahead and allow it, and then it's going to try to broadcast the transaction. We'll let that sit for a second, and when we come back, we'll see what's going on. But yeah, so we want to look at making an overlay because we saw that error before. So let's go to the Bitcoin SV overlay example repository where we can see some source code for some, overlays. And we've got data integrity service, hello world service, a few things in here. And I'm going to clone a copy of this repo just so that I can set a few of these up myself. We've got our, oh, interesting. Okay, so I'm going to clone overlay example. Did that not work? Oh. Okay. So just cloning the I'm just going to rename this. And here's basically just getting started with building an overlay network. Again, I only want one Git repository here, and if we open this up, I can install my dependencies first and foremost here. And I want to try to build this. And then basically what I want to do is let's go back to the UI because I started that process and I said I would get back to it here. So yeah, we can see that we created this thing, it got inserted into the system, but of course we've got an error when we tried to broadcast it because I showed you that code, and as we can tell, right, no host is interested in this transaction. That's because we tagged the transaction with a particular topic, in this case TM_meter, which nobody hosts yet. So we need to change that. In order to host an overlay service, we need to expose ourselves to the internet firstly, and do a few things like that. So I'm going to go and open up my index file where I can see a few things. I'm importing .env and Express and all of these things. We're setting up a database here for the overlay engine, and we're importing some variables here from the environment. I've got two options here. I can run this locally using Docker, or no, sorry, I can run it locally, or I can use use Docker Compose, and I think that the Docker Compose is going to be the easiest. We've got Docker Compose here, and we've got overlay example. We've got port 8080. And we got hosting domain. And if I go ahead and actually just set up an ngrok, and I was doing this a little bit earlier, I should now be able to get a, and this is public, so anybody can, just want to demo how to set this up here. I've got ngrok, and that's my hosting domain. So when I pull down the overlay example code, I can edit my Docker Compose. I can add my hosting domain here. Whoops, I've actually copied the wrong value out of ngrok there. So where's my terminal? Here it is. It's actually got to be this value. And I can then put that into my, right, that's my hosting domain. My great key, and then I'm just reading through, right, we need a server private key. I'm going to use a server private key that is funded with Key Funder. So I'm going to go to Key Funder, and I'm just going to fund myself an overlay services private key. I want to move BSV out of my MetaNet client, move BSV to a Ninja private key. A Ninja private key is a place where people can hold money. And then I'm going to generate myself one. And for the purposes of this live stream, I'm going to make this public. So I'm not going to try to hide this from you guys. If you steal my money, well, off you go. What is it? Random bytes 32 2-string hex. All right, so this is the private key that I'll be using for this tutorial. If you're doing this yourself, you probably don't want to leak your private key live on YouTube, but I'm just going to fund this key with a few satoshis. All right, the dojo URL, dojo. This is how you fund a private key in the overlay services ecosystem currently. And I'll just give this, 30,000 satoshis. That should be enough. If somebody wants to come on here and, steal all of my money, at least 30,000 satoshis of my money, which is about 2 cents, then actually I'll just congratulate you for learning how to use the Ninja tools. So there's your incentive. All right, let's just go ahead and set this up. All right, it looks like we've created the key. Now I'm going to go to Ninja UI and confirm that I've got some money in my new private key. So, whoops, I'm actually logged into a Ninja that probably we shouldn't leak on a live stream. So I'm just going to forget this key. Don't mind me. All right, let's try that again. Okay, so this time we don't want to, no, this is the key that I'll leak on the live stream, not my other one. This one, we'll just go ahead and go to, again, Dojo, and we'll log in. And here we can see that there's one transaction, and the current balance is 30,000 satoshis. Now this key has money in it. And I'm going to use this key to fund or to facilitate the operation of my overlay services instance. So I'm just going to paste that here into my Docker Compose, and we've got a TAL API key, which I'm a little bit more hesitant to leak that. I don't think it's necessary to have a TAL API key, at least for this system. Again, this is the overlay example. Okay, right, we're all set up here. I'm going to go into the code now and actually make sure of whether we're using the TAL API key at all. So in src, for this example, I'm going to go here. And for the overlay services, I'm going to go ahead and delete the TAL API key out of here, or at least find what's using it and maybe comment that out. I think the arc, okay, there's our arc config. So the arc broadcaster, I'm sure uses this somewhere, and hopefully I can just comment that out, right? So because we're not going to use this wait, do I need to provide an API key for that? I wonder if it is necessary. And maybe I can have an API key that, yeah, so what I'm going to try to just exclude the arc config because I don't actually think, okay, so because I don't care about Merkle proofs, I can still use Arc for broadcast without an API key. I just don't want to use the Arc config in this example. Right, so we'll just use that as our broadcaster. Right, we're setting all this stuff up, and for the purposes here, we've got our ngrok running. We've got all of these things set up here, and we're advertising a few services, but I don't think we're going to use most of these. So we've got Hello World, which I'm actually not going to advertise, because I'm not going to use that. UHRP, but we do want ship and slap. So ship and slap are the base level overlay services for host interconnect and lookup availability. We don't need them strictly, but it's probably like 90% of the time or more when you're using an overlay, when you're dealing with this stuff, you're going to want to set that up. Okay. So here we're setting up a few things. I'm just checking to see how this is configured. We can probably delete a few things out of here too, right? We got hello storage and UHRP storage, and these are some new storage engines for the Mongo database. So again, what I've done here is I've just cloned the overlay services example from the Bitcoin SV repository. And I'm now going to just delete a few of these. Let's go ahead and comment this out as well. That's not necessary. And I can got UHRP, all the UHRP stuff can be deleted. As well as the hello world stuff. It's not necessary in this context. Okay. Again, I'm deleting arc config just for this example. I would encourage people to actually set that up, but I will commit this private key to this repository and see what happens with it. Just as a little experiment on my side here. But I will not commit an Arc API key because that's their API. So for that reason, I'm going to disable that for this exercise. Okay. Or sorry, a TAL API key, not Arc. Well, it is a TAL API key for the Arc instance run by TAL that I don't want to commit here. So here we're actually setting up a known deployed slap trackers and everything. So that's fine. And so we've got sync configuration. I don't think we actually need to provide anything specific inside of here because we're not going to disable, we're not going to really change anything with our sync configuration. And now I'm just thinking here what needs to happen. I'm going to delete a few of these things that are not necessary. And, we're not using this anymore, of course. Okay, so, right, I've just kind of set up the overlay example here. Here we have some, HTTP related things. But I've configured this. I have ngrok running, so I think the next step is going to be to actually attempt to execute a Docker command to get this to run using Docker. Let me just go ahead and open a new terminal window here. And I'm going to meter overlay, and I think it's Docker compose up dash dash build dash D. And so we'll see, do I not have Docker compose? Let me try something else. I thought I had Docker compose. Does it Docker compose? I definitely have the Docker command. I'm just going to try this. I'm really not sure. Now I'm kind of on the fly here, guys. I'm trying to get my Docker compose to be working, so just bear with me for a second as I try to work through this. You know, I should be able to run a Docker container here. I did run Docker container ls before. This is for my local LLMs. It's a completely different project, but I now should be able to Docker compose, or maybe I have to source. Let me restart my terminal now that I did brew install that, just to see whether I now have more capability than I did before. Docker compose. Okay, up dash dash build dash D. Let's see what happens. All right, get. .127.0.0.53. Well, that's DNS related. They should have used. Okay, well, that's a bit of a downer here. I want to run my my Docker compose here up. But it looks like registry1.docker.io is having some networking issue or something. Okay, the string version. Okay, that's a bit strange. I don't know if anybody's in this chat here at all, but if so, yeah, it would be interesting to try to see. It would be interesting to try to figure out what's going on here with Docker. Okay. I'm going to try to resolve this issue with Docker Compose. I did think that because my Docker was working, I'd be able to run a Docker Compose file, but it doesn't appear that way. So I'm going to try to run this. One final attempt here. I'm going to restart my terminal here. And I'd just like to be able to run up this overlay instance that I've just configured here, if I can manage to do that. Here we are. Let's go ahead and I'm going to turn to ChatGPT, everybody, just to see whether I cannot get this to work. Starting with Docker version 20 was introduced as part of the Docker CLI. However, it requires Docker Compose plugin. So how can you install, install or update the Docker Compose plugin. Brew update, brew upgrade Docker. I can try to run this. I'm really not sure. Let's go ahead and try this, I suppose, just to try to get the overlay to run. So I'm going to exit out of this and actually... Oh, well, I guess I need that. I'll go to this one. Let's just run this code. Looks like we are now... Okay, now I'm going to try to chmod plus x. Right, I apologize for this, everybody. I could have been a little bit more prepared here, but I should be able to now get this working on my machine. And if anybody ever runs into this, maybe this will be a good solution for you. Docker Compose version, it looks like. Now I have Docker. Okay, Docker Compose up build -d. Okay, once again, we appear to be having a networking issue. It doesn't appear to be connecting to that. So let me just go ahead and try to debug this here, guys, live on air. This is really what it's like trying to work with things here. Sometimes, right? I mean, I can ping this, but it's got to be. Right, this looks to be a bit of a involved process here. So I'll see if I can't ping it. I don't think I'll be able to. Well, this is going to work because... All right, we can actually resolve the IP address though, right? So it's saying go to the menu bar and try to restart Docker on Mac OS. I don't think I have a Docker in the menu bar because I'm using something else. Yeah, so I have access to my Docker here, but the thing is, there appears to be an issue with DNS. Yeah, guys, I don't know how to... right, so I've got to debug my network. Let me just read through some things here, trying to figure this out. All right, but yeah, systemctl I don't think is going to be the solution here. going to try to make a guess here, but I don't think this is going to work, guys. Unfortunately, having some issues here. Yeah, there's no command for that. Yeah, I don't know where I would look here on Mac OS to resolve this. So I'm going to have to yeah, I definitely have. Yeah, I'm not sure why I'm seeing these weird errors with Docker here. So that's going to be a showstopper, I think. We're going to have to end this here. Let me check. Yeah, no, there's no. I mean, I'm gonna check. Let's see. I don't know why it's trying to use 127.0.0.53. It's not. I'll try to look through here just to see whether I can resolve that. But right, it's giving me Linux-based commands here. I guess it didn't specify them on Mac OS. My DNS configuration is definitely correct within that. I don't have Docker desktop. No, I'm using Colima, so I need to tell it that as well. This is definitely, let's see. So I thought before I started here, guys, that the Docker stuff was resolved. Colima status, I think that's going to be fine. Right, it's running using virtualization framework. All of that's fine. It's just going to be a matter of how do I actually get this to... Okay, Colima start DNS. Okay. Colima stop, Colima start -- DNS. I'm going to try that. Just running into some basic stuff here. Oftentimes it seems like all these layers of technology are building on top of each other in questionable ways. 1.1.1.1 or something. Okay, let's see if we can't get Colima started here with the correct configuration. And if we can manage to get this going, then it's possible that we can resume kind of fight through this here. Okay, so let me just it looks like that's running from 11 months ago. Oh, it's up 12 seconds still. Okay, now will this work? Okay, we appear to be having some progress over where we were just a moment ago, so happy to see that, guys. Let's see if we can actually get a container up, or a few containers actually. We're pulling down all of the Docker images and everything here for the overlay services engine. So just give this a second. And I thought I had Ethernet in this room. I think I do. While this is downloading, guys, I'm going to be right back. I'm going to plug in my Ethernet and see if that helps. So give me one moment. All right. Back at it here, guys. I've just got my Ethernet controller. I'm going to plug that in and see if that will help with any of our internet speed related issues here. Let me just connect the appropriate cables here so that I can get that going. Here we go. Okay. So I'm going to first confirm that we're still live. I think we ought to be. All right, let's actually check whether Ethernet is connected here. Okay, yep, now we're on the Ethernet, so that should be good. All right, perfect. Okay. So I'd like to just confirm once again that I am still going to be live. See. Just give me a moment, everybody, as I figure this out. Here we go. Okay. Yep, we are live. And all right, just wanted to confirm that again. Make sure that now that we're on the Ethernet, right, you switch network controllers. Okay, so I think, in theory, if I list my containers out here, and I'm going to make this terminal full screen, I should be able to, it's still going to, all right, well, that's fine. Let me make this back where it should be. Okay, so we do see some containers running. So we see Mongo, MySQL, and the actual overlay host. So let's go ahead and let's see. So we see overlay. See overlay example. I think that's this one. So if I say Docker logs, okay, we seem to be getting some errors here. Error during engine initialization. Error, no secure random number generator is available in this environment. Okay, so I think that the entry point for this server, can be updated to use TSX. So there's a thing called TSX that allows you to execute. Just seeing that error here. We've got index.ts. Let's go ahead and go to package.json, start. Just going to replace this with TSX. Get rid of type module out of package.json. Maybe even npx tsx. And then I'm going to check the Docker file. npm start. Okay, so I'm going to assume now. I'm going to pull the Docker compose down. I'm going to build. Looks like I got a looks like I got an issue here, or 30. We're getting some issues now with building. Am I actually needing to build that though? If I'm going to use TSX, I don't think I need to compile anything anymore. So I'm just going to see about whether I can bring this back up. Docker compose up build, and let's just see what happens. So it doesn't like that I removed that, but because I'm executing this directly, I have no need to compile the code anymore. I'm using TSX. Let's see how that works. Docker container ls, and we'll just go ahead and grab this container ID. All right. Now I need to make a post request. Here's where I'm going to rely on ChatGPT. Just again, give me a okay. I just wanted to, grab this as a little thing I can monkey code off of. So now I'm going to run my migrations for this database. So the real thing I want to do here is I think this is going to be something I can run locally. Just trying to run the migrations for the overlay services instance, localhost 8080, migrate, and it says status error code unauthorized. Okay, migrate key, and I have migrate key. Grate. Let's try with a lowercase k. Aha, I did migrate. Okay, now we've successfully migrated the database. Let's just go ahead and bring the system down, and then we'll bring it back up again. Now that that's happened, Docker compose up build. Okay, Docker, what is it, logs, and then let's try to actually, it's overlay, example, no, overlay, Oh, can I? Overlay example, I think. Okay, so now it's going to try to run a synchronization for a few things. That's to be expected. These errors are to be expected given some known issues with ship and slap, but that's not the focus here today. The goal is to run an overlay service and to get it working. So I'm just going to clear that, and then I think I can actually disable synchronization for ship and slap. Although, is that going to cause issues? I don't think it will. So I'd like to confirm a few things, right? We just got an overlay instance running, right? Like now there's this overlay that I'm running on my computer. So in a very roundabout way, that's how you do that. And it's got this private key. We funded it. Now let's make sure the database is working. So Docker exec IT hang on. Docker exec -it overlay MySQL u overlay admin -p overlay 123 was the password configured from the database, and now if I show databases, we have an overlay database. So use the overlay database, and then show tables, select count 1 from outputs. We've got 4 outputs. Select, let's just describe outputs here for a second, and we want to know the topic. Okay, so we've got some host interconnect and lookup availability records populating in our database. That is a great sign. So these TXIDs are going to be for, I think, fairly recent transactions that are now on the mainnet. In fact, they're all the same transaction because they're new. And I believe that if we actually go on something like even what's on chain here, we can search for the transaction here, and we can see some custom script output. So here we can see the ngrok URL. So it is advertising, and this is on chain. It's advertising the availability of the host interconnect protocol for itself, as well as a few others. So that's available for host interconnect, saying it's available for lookup availability, and then so both the topic manager and the lookup service are available. So this transaction is what actually put that on the blockchain. And now if we go back to something like the Ninja, where we actually can see the transactions made by this private key, we can see there's been a few. So we used a few of our Satoshis here to kind of set up our ship and slap advertisements. So that appears to be working now, everybody. That's great news. That means that we're actually on the network, right? So the overlay instance is now available and can be used. So that was a bit of a tangent, but basically it's necessary. You know, we set up this overlay network instance, and now we need to create an overlay specifically for this type of transaction. In this case, we're thinking about a transaction for the meter app. So we're using sCrypt here to set that up. Let's actually start building that now that we have a running overlay instance for our use case here. Let's go ahead and start to use it. So I'm going to copy the Hello World service. This has a lookup service, a storage, and a topic manager in it. So I'm just going to rename this to meter services. And when we look in meter services, let's go ahead and make firstly a meter topic manager. And and the function of a topic manager in an overlay network is to decide what gets into the network, basically, right? So here we're importing some types. We're using push drop here and some things like that. I should install our dependencies here just so that we don't. Oh yeah, we're seeing module build issues here. So that's going to be a problem, but I'm going to ignore that because I think it is working using TSX. So let me kind of zoom out here. We've got a Hello World topic manager. This is going to be meter topic manager. And I'm going to decide in a topic manager what outputs are admissible and what ones are not. So we're going to compute what, when we are in our front end, we create this output, and the output has a script, and the script represents a counter token. And the overlay is going to actually be responsible for deciding whether that makes it into the blockchain, or whether it makes it into kind of our view of the blockchain here. So, we go and firstly parse our transaction, and for each of the outputs, we start to decode this, right? And that's where we're going to deviate, right? Instead of using this push drop thing, which we didn't use on the create side, we are actually going to parse the sCrypt smart contract. And then all the other rules are going to go out the window, right? So, whoops. Right. This is a topic manager that would admit any output, but right, there's our output locking script in hex. And sCrypt contracts have this this ability to be used from a locking script. So in that context, we need a copy of our artifact and our contract code itself. So I want to copy that into the overlay services image here as it exists. I'm going to copy artifacts from the front end to the overlay. As well as the contracts. Now I should be able to copy some of the code we have in the front end for actually making use of the contract. So we'll go ahead and this here, right? Got the meter contract. I'm just gonna, within the topic manager here, I just want to import that from artifacts, and oops, and then I want to import the contract itself. Right. And then of course we have property. Oh. I think I need to install a dependency here as well. I don't think we need any of this. And we definitely don't need push drop here. But I should make sure that within the context of the overlay services, you know, sCrypt TS and sCrypt TS lib are installed, of course. We want to make sure that that's working. And now we should be able to actually load the artifact, just like we can before. Perfect. Okay, so now we have meter contract, and we should be able to make a instance of this. From locking script, which takes a string. There's no off-chain values here, so we just pass in script. And if that works, right, then we appear to have a valid meter contract. So we can now make assertions on that. But for now, all we really want to do is make sure that it's valid. So, you know, if I don't know, we'll log, you know, say ensure meter can be constructed from script. This is where other validation rules would be enforced. This is where other overlay level validation rules would be enforced, right? So you create a script, and this is saying script is assigned to value, but it's never used. But actually, it's used right there. So I'll just try to save this and see. Okay. All right, so that's a very crude but complete topic manager. You know, and I can update this. You know, this says get metadata, and we can return, you know, some metadata or something, but I'll just leave this unimplemented for now, actually. Okay, so there's our topic manager. And now we can actually see about getting this to work within the context of our overlay services instance. So I'm going to go back to index.ts here, where we set everything up originally and did our config. And I'm going to import the, I'm just going to import the topic manager that we just built. So that's how you build a topic manager, is you're really deciding the rules for what you want to enforce in your overlay. It's going to be called hello, or what do we call this? Meter topic manager. from meter services. Meter topic manager, okay. And now we just need to construct it. So down here we create a few of these. New manager for that. And tm underscore meter. Meter topic manager. Okay. So with all of that implemented, it should now be possible to rebuild the overlay and just kind of see what happens here. So if I've done everything properly, well, let's just before I speak too soon here, okay, I'm going to pull Docker down, and then I'm going to bring Docker back up, and we'll see whether this is able to come back up. It looks like it's running to a point. Just go ahead and check those logs. We're getting some errors. Error looking up topic tm slap. I see. Okay. It looks like we're getting some issues with. But I think. Let me check my. Let me check my Ninja. Let me see if we're making another transaction yet. It looks like we are. It's going to copy this transaction. I'm going to go to what's on chain, and I'm going to see whether this is doing what I think it's doing. So here we see 3 things. We're advertising. I'm just checking out some of this. I see TM meter. Okay, so I have advertised the meter topic manager, and what that means is that I am now on the meter network, whereas before I was not. So I want to. I'd like to see those logs. I don't know if I can get logs out of Docker Compose specifically or not, but I can. Failed to all right, well, I'm going to ignore all the GASP sync errors, but I think because I'm on the meter network now and because my ngrok is running, I should actually be able to go back to the user interface. And without making any changes, anybody on the meter network should receive meter transactions because of host interconnect protocol. If I now create one, I'm just going to approve this here and see how this works. So looks to be broadcasting, and I don't know if this is going to work or not. But what's happened is I've created an overlay service instance that implements the meter topic manager, this new network that I'm building, and I have deployed it and I've advertised it to the rest of the overlay network. There's issues here, and I have a known bug already written down about this timeout issue, where sometimes these broadcasts incur, network timeouts and things that really should terminate a lot earlier than this for resiliency's sake. But we're gonna address that. I'm gonna check the network tab though, just because I'm very curious. So it looks like we're running this stuff. Okay. I see lookup. I see lookup. I see a few things here. What's happened? All right, I'm gonna go check the console now. And it says no hosts are interested still. All right, so it looks like it did not successfully reach the TM_meter network, which is unfortunate. I'm going to go check the network tab again, though, before that gets too far into the past here. So we're using host interconnect protocol with overlay example. Just checking out some of these URLs here. Okay, post TM meter on ship. Response was empty. Okay, so I don't know that that actual advertisement has been getting out. I'm going to disable syncing, because I think that might be one of the issues that is causing some of these problems. Sync configuration. And that way I can actually read my logs a little bit better. So ship and slap, just temporarily, I'm going to disable the synchronization here, and I'm going to then try to bring this down and back up. This time, I'm going to not call -d so I can actually watch everything here. Looks like I've got an error from... Okay, that appears to be as expected. Okay. I don't see tons and tons of sync errors, so that's better. There's a few of those cannot read property, but it's not really what I'm looking for here. A few database related things, and if I now attempt to run this even again, I'm just going to try to create a transaction here. See if I see any. It's trying to broadcast. No, it's really just Mongo stuff. No real ingest on that. Yeah, so the goal is to create a broadcast of this transaction and try to get it into the TM meter topic manager within the overlay that we're actually just now hosting. And for that to work, the overlay has to successfully advertise to an existing set of trackers, the existence of that. So here we have known deployed overlay services node. So we got overlay.babbage.systems as the known. That's where they're going to kind of find each other. The issue is that, oh, I do see a submit. Wait. Okay, I think, let me confirm this. All right, so, okay, I think what happened is it just took a little bit of time to propagate. Or perhaps it hadn't reached the other node just yet, but now it has. So I think it did work. Let me actually check the console. I think that might have actually worked because, okay. Right, yes, status success. So sent to one overlay services host. All right, so yes, this has worked. This is a success. So this transaction, guys, contains a counter. And the counter that is in this transaction, I'll put the TXID in the chat of this live stream. And thank you, InfoCreate, for the message of support. I've just put that TXID, and that is going to be the transaction of the first Hello World token that is, or sorry, the first counter that is on meter. So there's the meter contract. And if we were to actually go and can check the logs here and see if we can actually tell whether that was ingested at any point. Looks like there was a few errors on previous outputs, but one of the outputs was admitted. I can see that by the network traffic here, and it did indicate success. So when I look at the network traffic, now we can see, you know, that we've submitted this and that the responses is here. Okay, so that's a great first step, right? Now we have an overlay instance that can receive these tokens from the application, and we can proceed with building a lookup service. So a lookup service is a system that actually will track these and allow them to be utilized. The lookup service for Hello World can be forked again for this purpose, and we have it already in that directory. Let me go ahead and just demonstrate that. So, right, we have the meter services. We created the meter topic manager. Now we're going to go ahead and create the meter lookup service. So I'm going to rename the Hello World lookup service to the meter lookup service. And I'm going to go ahead and see whether we can make use of the same import at the top for the smart contract. So let's go ahead and import that. Hello World service, or storage rather. I'm going to go ahead and rename that as well to meter storage. Okay. So you got Mongo stuff in here, Hello World record from types. Let's just rename this to meter record. UTXO reference. I should have just renamed that wherever I was going to. meter record. No. I just want it to be that. Right. Okay, so just implements a lookup storage engine for a lookup storage engine for a meter. Okay, we got meter record there. Constructs a new I'm just gonna rename this to meter collection. We're not actually going to create that index or anything. And so we're just basically going to create a lookup service here that's going to store and then be able to retrieve these records upon request. And that way we can actually get them back in our application. And that's where we're going to start to use, the lookup resolver and be able to have this public data set. So let's start to think about how that's going to work here. Obviously, we're going to need to be able to store a record here. Store records of this code has been copy and pasted so many times now that some references to things that aren't even in the original code. TXID, output index, and then the message is actually going to be the value. So we're just going to meter value to save, store record, TXID, output index, and value, which is just a number. Okay, promise void, and then we just insert the record. So this .records.insert one TXID, and then we can say value. So I'm just going through and creating that record. Now we've got a deletion. So we've got the TXID and the output index. So that looks to be still properly implemented. Okay, helper function to create. Okay, we don't need fuzzy search or any of that stuff. Find by message. Let's see. Just reading through here. I think all we're going to use is find all for now. Someone can extend this further to have better finding, maybe find by creator, but we don't even have a creator yet. We only have a value. We're going to be very simple at the beginning. We'll add additional things later. The goal here is to move as quickly as we can towards an MVP, and then we can do other things after we get there. So just go ahead and I'm reading this. It looks to be correct. Okay. There will be no additional custom query things yet. Okay. So I think that's all that's necessary for the storage engine, right? Of course, the meter record, we'll go ahead and set the types up for that to make sure that everything is going to be good. Let's see, types.ts meter record. I'm just going to copy and make a new. value, just a number. Okay, we got meter record, and I think that means that I could now go into the meter storage and see about whether that's going to be where it should be. I think that's everything in there. Now we're ready to implement our lookup service. So we're importing those things from overlay example. Once again, I'm ignoring the common JS issues here, just because that I did actually bring that import in, so I don't need push drop anymore. We're not using push drop here. We're using sCrypt for a change for an overlay service. So we're using script here, get documentation. Okay, all right. Implements an example meter, implements a meter lookup service. Note, push drop package is used to decode. Actually, note the sCrypt contract is used to decode meter tokens. Okay, this is going to be called meter lookup service, implements lookup service, constructs a new meter lookup service instance given a storage, and we already implemented the storage engine. So now when an output is added, you have txid output index, output script, and topic. So if topic is not tm meter, then we don't care. And now we should actually add some exception handling, because there's no exception handling in this one, but we should say try, and then in case we can't, then, well, nothing you can really do, just, you know, return or something, just like we did if it's not the right topic. We got to decode the meter token. From the Bitcoin output script with the contract class. So here we're going to say const meter equals, once again, meter from locking script, and here we're saying that txid is a string, output script is a script. It's got to be 2 hex. Okay, we're making the meter instance from the locking script here. And we can now index this into our database. So our value is equal to, I believe, just meter.value. What is our, is it count? Or is there actually a, let's see. It is a smart contract, but actually it's as meter contract, I believe. So we're forcing the type to be correct. Meter dot, I think it's count, because we're building a counter here, so you can only increment it right now. But we'll get there much later. So that's a big int, I think, and we need a number. So I should be able to see, value is, yeah, big int. So we need to say number, convert the big int back to a normal number. I think you can do that. And we just got to pass the value into the storage. Okay. Error indexing token in lookup database, and we'll just log that error, I suppose. Okay, so now we're successfully handling the event when a meter token is added. We're storing it in the lookup service database. So that's done. When the output becomes spent, then if it is a meter output, then it will be removed. When it is deleted, if it is a meter output, then it will also be removed. So there's a difference between being deleted and being spent. When the output is spent, it could be retained for historical purposes within an overlay. When it is deleted, it is no longer retained, meaning somebody let go of the end of the chain of things that encapsulate it. So there's historical token management implications there. But here we're taking a lookup question and we're answering it. So if query is null, we got a problem. If the service is not ls_meter, we got a problem. If it is find all, then we do that. Otherwise, we got a problem. Okay, so we have the query there, and we're setting it up correctly. So now we can actually answer queries from our lookup service with the appropriate data given the meter records that we've stored. Get documentation, right? All of these things, they appear to be here. And I believe, I'm going to just search for hello world once again. I think that's not an issue. Nope. Okay. Great. So now we have a storage engine and a lookup service, and we're ready to plug those into our actual implementation as well. So back to index.ts where we've been working before, and I'm just going to model this off of other things that we've got. So I think I need to import this out of the other directory. So we're just going to import meter storage from meter services. Okay, and then obviously we need the lookup service as well. So I'm going to copy that and do the same thing. So once again with meter services, meter lookup service. Okay. Now I should be able to configure the system here to work. Let's just go ahead and create a new meter service. Meter storage. And then we need ls_meter. So it's going to be ls And then this needs meter storage. All right. I believe our configuration is now complete for both our topic manager and our lookup service. I'm going to save this here, and then I'm going to bring our Docker down again and back up. So let's go ahead and terminate that, and then bring it back up. Okay, so just waiting for things to come online here, checking out some errors as expected. Okay. Let's now turn our attention back to the front end. So on the front end code base, we have the ability to send a transaction out to the overlay. So let me just open up the front end here. Once again, app.ts, and I can import lookup resolver from this. And what I want to do now is, previously to this point, we had some dummy data put in here when things were loaded, right? But what I want to do is, at least partially, I want to use real data. So let's go ahead and create a lookup. I think that's optional, and then we can say. Now we can ask a lookup question, which has a service, in this case ls meter, and a query, which has find all true. Accidentally used a semicolon. Okay, so now we've got some records here, and I'd just like to see whether we can make a query here. So I'm going to console.log the lookup result. I'm just going to save this here. Then we'll go to our front end and actually see what's able to be found. So I believe there's those issues with things taking quite a long time, and we've got to figure out what that is. Again, I didn't note that earlier, so I'll get to that point. But I believe that the lookup resolver takes a while. That's why it's loading. I believe that's always going to take, until we fix that timeout issue with unresponsive hosts, because anybody can be a host. It's just if you're unresponsive, there is resiliency built into the system, and we just need to decide on a more sane maximum time for you to start responding. Okay, so got some runtime errors. No successful responses from any hosts. All right, so what happened there? We tried to run a lookup, and it didn't work. So I'm going to see whether once again there was an issue with propagation, where the overlay that we're now running is not contributing to a lookup service that is correct, or whether there's another issue. I'm just going to refresh this and check the latest advertisement transaction for my overlay instance. See what it's currently doing. I did, after all, disable that sync feature, but I don't think that's going to prove to be the issue. Okay, here we're creating a new advertisement using the lookup availability protocol. We are using our ngrok URL to advertise ls_meter. So that is correct. And that should be out there now. So it might just be taking its time to propagate. I'd like to know whether existing hosts know about that advertisement. That would indicate it's possible, but I'm just going to see what pops up here now. As we try to facilitate this lookup process, there are some hosts which obviously are not going to respond. For example, the ngrok ones. The office. We're running one overlay service instance out of our office here at Babbage. And that one is taking its time. There's some pending requests that are outgoing, and those are the ones that, I think are going to be the most difficult to work with here. I do see some. I wonder what this was in respect to. Oh, wait. Did it work? I do see an outgoing request here to overlay.babbage.systems. I believe here we're querying the meter service. Or no, we're querying the SLAP, this service lookup availability protocol service for the meter service, asking, does anybody host that? The response is yes, in fact, there is one who does. And now, no successful response from any host. But I wonder if it is reaching it. And I wonder if, okay. Unknown query type. Once again, okay, so I think, let me check my code again here. I think this might be closer than we think. So service lookup, we're checking the lookup service, we're checking the query type. Question.service, and then question.query can equal find all. Needs to equal the string find all. So if I now go to the application, and I instead modify this to say something like, I believe the query needs to equal the string find all. I may have just mistakenly done that in my lookup service, but I do see a query coming in, meaning I do believe that while this is slow, it is actually starting to work here. Whereas before it wasn't. We have to wait for these pending requests to actually time out before anything will show up, because once again I have those bugs. I have this known issue here, as I've noted already, that we're waiting for the slowest hosts to time out before we end up actually doing anything useful. And I think that we can definitely improve that, and we will. However, I think that once this does come through, we should be able to see whether, okay. Once again, waiting for those slowest unresponsive hosts to finish resolving themselves so that we can, so we can get this to work. I think the request timeout here is approximately between 30 seconds and a minute. Okay, so those finally timed out, and then our successful queries went ahead. It called lookup, and then what happened? If I look at this lookup request, which was made right here, I can see that it's an empty response. So the payload, we were asking the query of find all to the correct place, so it found it on the lookup availability network, and then it gave a startup lookup result with an empty output list. Now, here's what I want to test, right? Right now, that lookup service is empty. There's nothing in there, but it did return a result, right? So if I actually go ahead and create a new record, the question is, when I go broadcast that record, and again, we have to wait for the slowest hosts to time out before this will actually work, but I think it will. If I broadcast that, and I will have that fixed, like that's really annoying, guys. I really wish that wasn't the case. But if I go and once again, I'll close out of this network tab here, and I can see those pendings, those pesky pendings there. I wonder if I can terminate them as I look at them. Cancel request, or I don't know. Override headers. No, I don't think I can really interfere with that process here in DevTools. It would be nice if I could just cancel those pending requests, but we have to wait. However, I think at the end of this, I will have successfully created a token, a counter token. I will have successfully put it onto the network, and then we can see whether we can parse it out. And if so, then we'll have implemented our, okay, those appear to have timed out finally, and we can submit. There should be a submit in here. I want to check the value from that. We're submitting to this place. We're seeing a response with topical admittance successful. I'll check this over here. I think this is going to be indicative of that. We're logging the contract instance here, which appears to see that there are, there's a count of 1. Other things are being logged as well, but let's go ahead and refresh this page, guys, and see whether we have something in that lookup service. So before, when we saw that in the console, it was empty output list, and if this has been successful, then by the end of this, we should have successfully created a lookup service that indexes those meter tokens, these sCrypt smart contract tokens in our overlay here, and it should be available. So again, dealing with this very annoying bug with the timeout, where it's taking all of this time, but now it looks like it loaded, and we got a result, and we can see that there's 1 output in the list. And when we open it up, we can see the output index of 0, and we have the beef there. And that can be used to actually parse out our count here. So currently we're putting in some dummy data with a count of 42. But now we have an output list with a beef result in it. So we're now performing a lookup from this overlay that we've just created that indexes these things here, and on startup. And so we have this, it's type output list, and what I want to do is actually go through each of these and parse them. So we need to parse out the value, the creator identity key, the token, of course, which in our case, we're going to need to hydrate with what was in the beef data. So let's just go ahead and create a That's an array of meters. Lookup results.outputs, which is what, possibly undefined. Lookup answer. I was certain that, I'll check the value here. Yeah, outputs. Type and outputs. That's correct. Each of which has beef, I'm certain of that. So. We've got a we need to enforce that that is in fact the case. Now we can iterate over that because we know that that's the correct type. The compiler is smart enough to know that. Okay, so now we have a result. We should have beef and output index. So let's go ahead and tx equals okay. We need to pull out the script for the output that we're actually going to parse. And that's a string. Now we can make a meter. Dot from locking script. And now meter is a contract that has a value. So we can say as meter contract, okay? And so parse results.push, and we need each has a value, which is a number constructed from meter.count, a creator identity key, so we're parsing out our values that we got from our lookup result here. And then it also has a token. And then here's where we need to actually go to envelope from beef to get our token back. Of course, that's undefined because we need to create the token for the correct thing. Okay. So there's the to envelope from beef, the converted token, which takes a one of those and it returns as token. Output script. I'm going to kind of gloss over this for now until actually we get to what token needs to be. My goal is to parse this and get it actually created. Okay, so now we can set this equal to parsed results. Okay, so the theory is that we should actually be able to see the records from the overlay service on the system now. So rather than seeing 42, we should see something with a count of 1, which is the one we actually created in real life. And anybody else that pulls down this code, anybody else that runs this overlay services instance or this topic manager and advertises the availability of their lookup service, etc., will all be connected. The state will be shared across all deployments of the system, and it's fully resilient. So there's no reliance on anybody's thing to stay online, really. Of course, the ship trackers, or slab trackers rather, the only exception to that, but it's not a very big centralization risk, and also you can have a lot of them. So again, as we wait for that pesky timeout, once this loads, we should see whether we're successfully parsing these records. And that would indicate that we've successfully implemented an overlay service. And there we have it, guys. It looks like we can now see a real increment, a real meter that has been deployed. So this is the very, very first time I think that a real sCrypt smart contract has been used to track some value and then have that integrated with overlay services and pulled out in a lookup service and everything like that. Pretty big milestone here, guys. I think what I'm going to do is I'm going to commit this code here, including that private key. We'll see if anybody steals my money. Be a good little experiment. See if we can't teach anybody how to use the Ninja UI and all of that. So anyways, I'm going to pull this down for now, the Docker things, and just, yeah, I'll go ahead and write my commit here. So we'll just go ahead and say, let's just say implemented overlay service. And that's how you build. Let's see, and that took a very long time. Just want to make sure that we didn't commit anything too large there. No, we didn't. We're good. Just push that extra commit up to that repository and give it a little bit of time. And there it went. So there you have it, guys. I think that's going to be about part 2 of this little live series we're doing here, where we've been able to implement an overlay service that utilizes an sCrypt contract within the BSV blockchain. Some tentative plans for part 3 is maybe we'll actually be able to spend our little counters. I'm going to fix the bug in the TypeScript SDK that makes it wait a long time on lookup resolver. We don't want to wait for the slowest node to respond before we do anything. So we were gonna actually have that resiliency there and get that in order. And then, yeah, we'll maybe see about getting this identity badge to actually be part of the contract. Maybe somebody signs and then we link the signature back to their identity so that we know who's who in the system. And then we can have a global shared state of a whole bunch of counters that can be incremented and decremented within this application. So I think that's a good stopping point here for today. You can check out the code. I'll put the link in the let's see, in the chat for our live stream here. Let me just go ahead and do that. Yeah, I think that's going to be a nice little way to end things here. Right. Braden is saying we can set a explicit lookup resolver. That kind of gets that where it needs to be and resolves that. And I'm going to look into that further. But yep, this has been a good little example of integrating sCrypt with overlay and with Babbage's identity solutions. And really doing it for the first time, breaking some new ground here with some of the new open source components of the BSV blockchain. Lots more to come in the future, so stay tuned, everybody. Thanks for tuning in, and catch us on the next one where we'll actually tie some more of the pieces together. But this has already been a huge success. So we'll tweet out, of course, when we go live next time, and let everybody know. So catch us on the next one. Thanks.